So a very warm welcome to Dr. Muhammad Ridha here today with us. And before we begin, I would like to introduce to the audience about Dr. Ridha. So Dr. Ridha is a senior lecturer in the Department of Mechanical Engineering and an associate member of the AMMP Center at the University of Malaya. He obtained a Doctor of Engineering from Utsunomiya University, Japan in 2015. Prior to his doctoral study, he worked in Yamazaki Mazda Corporation as a senior mechanical design engineer, focusing on CNC machine design and evaluations for mass production and customization. So currently, he's collaborating with the Joining and Welding Research Institute, JWRI, Osaka University, Japan, to promote the friction stir welding process to be implemented in the manufacturing industry in Malaysia. The project explores the possibilities of joining similar and dissimilar materials such as polycarbonate, aluminium, or aluminium with stainless steels, and so on, for the lightweight applications in the automotive industry. Now, in terms of relation to topic today, in managing of the current pandemic, Dr. Ridha also developed a Mask Sterilizer machine to disinfect N95 for reuse, and also design an aerosol collector during dental treatment for infection prevention. So a very warm welcome to you, Dr. Ridha, and it's our utmost pleasure and honor to have you here with us today.
Thank you, Theo. Thank you for inviting me for this podcast session. Okay. Yes, we can start the discussion.
Yes, sure, Doctor. So, okay, we'll start with the first question. So, the topic here today is the development of a mask sterilizer machine to disinfect N95 for reusage. So, what was your motivation, or what gave you the idea for this mask sterilizer machine?
Okay. As an engineer and also as a design engineer, okay, the nature of our work is to design, to invention things, for the benefit of the people. Okay. But for this particular innovation or invention, actually we received input from Prof. Dato' Adiba that there is a needs to design and develop this kind of device. Then we had collaborators from a company that they invited us to design and develop this device during the MCO. So the nature of and design engineer always want to design new things, but just design new things without any input or any needs is you don't feel so motivated. So when we receive this call, okay, from the community, that there is a needs, there's a requirements, means that it could be useful for the people. Therefore, I become very anticipated, very motivated, and very enthusiastic to start this project. And it started during the MCO when we all locked down. I did the design, improved the initial design, and then we fabricate some of the parts. We did machine in-house in the Department of Mechanical Engineering. Other parts we outsource from outside, And there are also some other parts, like the quartz glass we bought from overseas. So you see, it's an effort, and because we are the designers, so these are the process that need to be done, and because of this input from the community, from the doctors, from the people that made us initiated this project.
I see. So now, if talking about like input from the community, right? So if COVID-19 had never happened and this input had never been given to you, would this sterilizer will still be relevant and still be invented? What's your opinion on that?
Yeah, the basic concept of the sterilizer on the machine is actually using UVC, C range of the ultraviolet rays to destroy the virus protein or DNA. So not only COVID, actually it can disinfect various type of viruses, bacteria. So this theory or concept or technology is not new. It has been discovered long time ago. So it's very old technology. But we use this old technology in this application. Okay? This time for COVID, but also it has a lot of functions. It can disinfect any surfaces, even without, in the case of COVID, for example, in hospital applications, in surgery rooms, operation rooms. So I think it has a lot of functions. Just for this particular case, the use is for N95 mask. Okay, but in actual application, it can be any item that you want to disinfect.
Yeah, I totally understand and agree with that. Yes, and now since you gave us a little bit of like hints and bits and pieces about like how you guys develop the machine itself, so would you mind delving into a little bit more details on like what are the steps and procedures involved in the development of this machine, such as like the planning phase, the designing phase, prototyping, this and things like that? Yep.
Okay, it involves actually several stages. Okay, the very typical product development process actually starts from the people. What do people want? Okay, in this case, people want mask that is reusable. Okay, so the scenario or the background of that project was that in the case of mask shortage for the frontliners in hospital, where N95 mask is necessary. So in that case, some masks might be or could be reused. So to ensure that mask is free from COVID-19 virus, so we need a method to disinfect the mask. Okay, so we receive a initial design of the machine. It's a very open inside. Then we just put the mask in the machine, and we have protocol from FDA, from the USA. It states that it needs to be disinfect or under or exposed under the UVC for a particular intensity and for a particular period of time. Okay, so based on this protocol, okay, we designed a machine that can be used not only for one mask, but for a multiple number of masks. In this case, we decided that initially we do 9, so 9 masks. Okay, so we have an array of 3 by 3. Then we put the mask in the tray, and then expose it under UVC top and bottom for 7 minutes. Okay, but there was always an issue. Okay, our collaborator Victor, he concerned about the cross infection between the mask during the disinfection process itself. He mentioned that what if one of the masks got virus and the other mask is clean, but we put in one container, then it could infect the other mask, then it could possess a risk. Okay, so that become the user requirements, design specification requirements that I need to solve. Okay, so we decided that inside that machine, we put individual container. Okay, individual container made of perhaps cheaper material, acrylic or any other plastic. But as I did my study during that time, I found out that normal plastic will block UVC. Okay, so as far as I know, there's only one material that fully let UVC rays pass, which is the quartz glass. So the quartz glass is a glass that you normally see on your watch, on your expensive watch. It anti-scratch. It's a very hard material, and having that, of course, it is very expensive. So this happened during the MCO. So I tried to find this glass where we can acquire it in a sustainable cost, a cheaper cost. Okay, so we managed to use the quartz glass. Initially, I wanted to use it for the box. So we have this individual box. When I consider the cost down, then we decided to put the quartz glass on the top and bottom of the box. So assuming that the wall of the box would not really blocking the UVC rays, because we have a lot of bulbs. I couldn't remember. We have a lot of bulbs, UVC bulbs from the top and bottom. I think it has sufficiently exposed the part of the mask from top and bottom. Even we use plastic acrylic sheets as the wall of the individual box, because most of the light come from top and drop bottom. So we use the quartz glass material for the top and bottom cover of these individual boxes. So based on that, and then we did that. For the other mechanical parts, there's a lot. The covers, the slides, the bearings, and the wirings, the brackets. We managed to manufacture it in the faculty, and some we outsourced from local manufacturers. As a result, we managed to produce the machine with individual box to prevent cross-contamination that works based on the protocol. Within 7 minutes, it could 100% kills the COVID-19 viruses on the mask. However, the drawbacks for that system is that the UVC itself could cause the filtering function of the mask to reduce if used for multiple times. Okay? So that study has not been done yet. Okay? Has not been done within this project. Okay? For literature review, for other papers, okay, we have seen study being done, and we acknowledge for several types of N95 masks, the filtering function will be reduced. So there might be a limitation on how many times you want to reduce the mask. As for the design itself, this is the first time we designed the machine, the device, and we managed to produce. I think it's almost near commercial level machine. Except that, from a mechanical design point of view, there's a lot to be improved. For example, the current machine weighs about, I think, more than 50 kilo. So I believe it's something that we can work in the next improvement stages. This could be or should be reduced to about maybe 30 kilo by reducing using a correct material, reducing the cover thickness, and so on.
I see, Doctor. So when you were designing the machine itself, did you have any reference or anything to design it based on, and anything like that?
Yes, it was actually based on initial design that does not have quartz glass box. We received the design from our collaborator in the US. It was for one mask device, so we don't have the concern of cross-contamination among the masks. So based on this single mask disinfection machine, we improved the design, and we add more space, and we add this individual quartz glass boxes to prevent the cross-contamination. I believe that there is the novelty point of the invention.
Yes, I agree so too, Doctor. I believe it's a big improvement upon the first concept that was given to you, and I think it's a very, very beneficial improvement. So how do we, as from a perspective of a consumer, operate the machine potentially in the future when it goes to a more commercial use. So is it simple to use, or is it quite complicated for the consumer?
It's actually quite simple. Only that if we can add automation function, it could be improved in terms of user-friendly, maintenance and ergonomics. Okay? Human tend to make mistakes, okay? But we can prevent that using design. Okay? We could add a function to automatically lock the machine and release it only after the after 7 minutes or after the disinfection process has been completed. So there's a lot of improvement that could be made. I'm working on it to go through the right channel to work on this improvement with my teams. And then I think the one that we have provided to the GOTGM could give us good input on proposal of improvement, because those are the real person who use the machine for disinfection. So the feedbacks from the field test, I would call, will be essential.
Yes, Doctor, I absolutely agree with that. And I think since it is more steered towards the use in the healthcare system, do you see it in use for the normal household setting as well?
Yes, initially it is intended also for the heavy use scenario or background in the big hospitals, but it could be applied in household. We have seen UVC devices. For example, recently one popular electrical appliances maker has developed their UVC air disinfection. Okay, so it used exactly the same technology, because you see the concept is that we wash our hands, we wipe the surface, okay, but we couldn't do much on the air. Okay? So that's where the gap or the loophole, because the virus transfer basically on the air aerosol that we breathe, or the contact of surface, the skin that we touch through fluid transfer. So basically only these three methods. Okay? But we wash our hand, we wipe the surface, we couldn't do much for the air. So the technology to disinfect air, I believe, is what we need now. Apart from the vaccination program, yes, but this is what more that we can do for the next step to cleanse the air. So using the same technology, the device or the technology UVC could be applied in many areas of the household. Maybe not the same machine, but I'm referring to the same methodology, same technology, in order to reduce the infection or kill the virus.
I see, Doctor. So in terms of like, if it was if it were to be open to the household use, what would be the cost for it, and do you see it as being a affordable device for just normal citizens, or what's your opinion?
Yeah, during the development of the machine, actually, apart from the quartz glass, quartz glass was intended to let the UVC pass, but a lot of cheap material blocks the UVC. So if we not considering this individual quartz glass material, the other material for that machine is all cheap in the cost, except the UVC bulb itself. So the next expensive parts in that device is actually the UVC bulbs. So these UVC bulbs actually contains mercury, and therefore it's expensive. Not familiar, however, with the technology to generate ultraviolet rays. Okay? But I did some study. It contains mercury, and therefore the process is a little bit complicated. That what makes the cost is quite high for the bulbs. So as long as it is in high demand and can be manufactured in a huge amount, I believe the maker could reduce the cost. And in this case, I believe the machine could be made more affordable.
Yes, Doctor, I'm looking forward to it being more affordable as well. Now, since we're talking about the UVC bulb, so I would like to add an additional question upon that. So, how was the effectiveness of the machine tested, and was it in the laboratory, or how is it done? Yeah.
Okay, we had the machine tested by T-Direct. Okay. Before that, yes, the technology is already, it's already old, and many research papers already tested the efficacy of UVC on COVID-19. But to confirm that, we did the test in T-Direct, tropical tropical infectious disease research institute and education, okay, which head by Professor Zali now. Okay, so we had tests being done over there to expose the virus on the mask, expose it on UVC for 7 minutes, and we study the virus viability after that. And for that particular condition, we confirmed that the virus has been killed.
I see. That's a very clear explanation, Doctor. Thank you for that. And since you mentioned it is already an old technology, so has it been implemented in the healthcare centers worldwide, or will it be in the future? What's your opinion?
I think in the past, the main concern for this UVC method to disinfect virus was that you see it destroy virus and bacteria protein, as well as human protein. So if you expose it on your skin, you could get skin cancer. And if you look at it frequently or in a long exposure, it could destroy your retina. So, aspects in terms of safety when you have it as an electrical device in household, particularly, or in a place that is not fixed, in a location with children, for example. So it could be high risk and danger. It is effective, but it also have some drawbacks. So I think because of this concern, and that this particular method, even if it is efficient, therefore it is not being so much popular as compared to washing hands or using alcohol to disinfect surfaces. But the move has been a research direction towards UVCB, if I'm not mistaken, sorry, which also can kill the COVID-19 viruses, coronaviruses in this case. But it is safer for human. So I think it's within that range. It's safe for human, but it can kill the virus. Perhaps the efficiency is lower than UVC because it has a lower energy.
I see, Doctor. So in terms of like talking about effectiveness, so so far since you mentioned you have given kind of a first or a prototype or the latest stage of the machine to UMMC, and what was the input from them? What was their response? Is it like a very, very useful device for them, or how was it? Yeah, what was their response?
I have yet to receive input from Victor, but I hope I will get some feedbacks from him based on the real person who use it, maybe the nurse, the doctors. So based on these feedbacks, I'm looking forward to improve the machine, improve the design, of course, and also if it's good, then we should get some recommendation to sell it more.
I see, Doctor. So I know you mentioned this just now, but just to confirm to the audience again, so like, can we just keep sterilizing the mask infinitely, or is what would be the recommended limit for now for the reusage?
I think for that particular machine, using UVC, a couple of times would be, I think, no problem, no issue. 1 or 2 times, okay. We can put in the machine, sterilize it, then we can use it. So perhaps you can use it for 1 or 2 days. Okay? When you disinfect it, you use the next day at work. Okay? But beyond that, I think thorough study need to be done, okay, to evaluate the filtering function of that mask, because this UVC itself, it has these powerful rays and also generate heat that will significantly deteriorate the mask filtering function over a long period of time. if you continuously keep expose it.
I see, doctor. So also you mentioned that the UVC light rays are very powerful and could potentially be quite dangerous to the human eyes and humans, affect the humans in general in a bad way. So what's your opinion on like the advantages versus the disadvantages of this mask sterilizer to disinfect the mask? Yeah.
We didn't compare the efficiency between using UVC and using alcohol, or using this other method also, maybe hydrogen peroxide, a cheaper version, or using soap. Okay. And this other technology also using plasma, or only using filter for in terms of filtering the air. Okay, filter, we have HEPA filter that could filter the virus itself. So we need to compare the efficiency of all these methods, and then I think some discussion on the advantages of using UVC could be presented.
I see, doctor. Thank you for the explanation. So also just to clarify another kind of like myth, so can the sterilizer also be used to clean other surfaces or other materials other than the mask material?
Yes, definitely. It can be used to sterilize almost any material, but the concern would be on the plastic material actually, because study has shown that the UVC accelerate the plastic life. I mean, it could become peel out, cracks in plastic due to the UVC itself. However, for other material like glass, metals, seems no issue. So the plastic, this also happens over a long period of time. It's not instantaneous, but maybe until a few days or months. But definitely it could damage the plastic material.
I see. Thank you, doctor, for that explanation. So now we'll steer a little bit away from the mask sterilizer machine itself. We'll go a little bit more general. So what are the future innovations that have the potential to kind of revolutionize the medicine in handling infectious diseases from the point of view of engineering? And also, have you seen any like ongoing or developing innovations that might be coming out soon?
Yes, I think since COVID-19, we see a lot of innovation in medical field, particularly like the shower unit to disinfect virus using hydrogen peroxide and so on. But one particular concern is actually in the field of dental, where we have some diseases. Maybe we can wait or give prescribed medicine, but in the case of dental patient who seeks dental treatment, because through mouth cavity, if that patient has COVID-19, this could possess very high risk to the doctors and nurses. Okay, so this is one of the areas that we've seen some innovations, and I also have engaged in a collaboration with Prof. Jacob, Associate Professor Dr. Jacob from Dental Department, and we are developing some device for the use of containing the aerosol generated from the mouth cavity during dental treatment to reduce the risk of infections to the doctors and nurses.
I see, doctor. So apart from, just out of curiosity, apart from the aerosol collector for the dental treatment, are there any like side projects that you're doing or developing, if you don't mind sharing to the audience?
Yeah, I always want to invent things, but you see, we need opinion. We need to hear from people like you, then medical students. Okay? When you go doing your practical, for example. So what are your main concern for infection, preventing the infections? So based on these feedbacks, inputs, we design things based on the requirements, based on the needs. Only by doing that, we could design or we could invent something useful. Because just design something not based on actual user needs, so it could be useless. So based on your all inputs, I want to design something.
I agree with that, doctor. So since we're talking about the bridge between engineering and medicine, so do you think that engineering is closely related to medicine, and what's your opinion on the future of both of this industry working together?
It's definitely closely related, but it's a matter of do you feel it's related or not?
Yes, I do. Yeah.
So you see, the CT scan, the MRI scan that you are using, to diagnose diseases, all those are based on scientific evidence, so based on principle, to see the human organs, there's something odd in the organs, right? I love to watch this hospital drama, so I knew some terms, but I think it could be, the next maybe the next generation of CT scans or MRI. I wish it could see clearly the boundary of these organs, perhaps also the artery, those blood vessels, without any additive, particularly for the angiogram, right? You need to put some additive in the blood, right?
Yes.
To be able to see those in the blood vessel, the pumping of to the heart, right? But
That's correct.
I believe in the next technology, where we can do that, because you see, like CT scan or MRI, you could see the section. Mostly you're looking at the section, right? CT scan, the section cut of,
Yes.
of the human body, right? Why could it I think the next generation would be showing that in 3D. I've never seen MRI or CT scan showing the result in 3D, because the original file is in the section cut. The next step that we can do is we can generate 3D model out of that section cut file. So I believe it could be more interesting. Yeah, 2D, you see, sometimes you miss out something in imagining the shape of that particular irregularities, right? But if you can view that in 3D, you can, I think, on the spot you can see, because that those how many pictures you have to see at that particular depth on that particular picture. But if you can make a 3D, you can just see all that picture in one model. So I don't, yeah, I was just my imagination.
Yes, I totally agree with that. That would definitely benefits the doctor very much in terms of diagnosing and seeing things clearly. So this is an additional question from me again. So since you talked about the development and the advancement of the engineering industry, so do you see the possibility of like the advancement of machine learning overtaking the medicine industry or the doctor's job in a sense? Yeah.
I watched this in a drama, in a Japanese doctor drama, where they use AI to detect diseases. So the AI, of course, has all the database. So based on the symptoms, the condition of the profile of the patients, so it detects. At the level it could detect the disease, but what it don't have is it don't has human touch. It don't has human inside this AI system. Yes, it could be perfect, but it could help you in some of the cases, but I don't think it could help in certain cases where it miss some, perhaps it could miss feelings. Yeah, we know that now AI also can detect feelings, but it could not detect hidden feelings. This is I think the limitation. But I also agree, definitely at the now maybe it's still low level, then it surely can improve and getting better at diagnosing. But there always a limit where you need human to do it.
Yes, I agree so too, doctor. So it's like machine could never really replace the human interactions.
Yeah, the drama, did you know the drama? The Japanese drama about this one?
I'm not too sure about that, but maybe you can recommend to the audience.
Okay.
Yeah, maybe Dr. Ridha, you can recommend it to the audience. Maybe you can mention the name for it. Do you remember the name for it?
I'm so old.
Okay, no worries, doctor. So, all right, coming down to last few questions.
Dr. X.
Dr. X.
Yeah, Dr. X, right? Yeah.
Okay. So yeah, I think the audience who are interested can search it up lah. So now we're down to a last few questions. So do you see enough engineers or medical doctors working and contributing to innovative medicine, engineering in general, and how can we encourage more medical doctors to contribute in this innovating the new machines for the medicine?
I think both parties, I think, doctors, medical field and engineering field, we should continuously improving our skills. Skills in that's what the spirit of lifelong learning. When you are at a certain field, that should not be only your scope. Because if you want to solve big problems and help more people, you definitely have to venture into the other field. Engineering, you're only looking at machine production line. You're not going to improve and expand your research and your capability, but also to look in not only medical but any other field also. And that seems for the doctors, perhaps relevant life skills, maybe something related to IT, technology. So how we can use this to improve the efficiency in hospital procedures. I've seen there's a lot of improvement. For example, when you have your X-ray at the level 4 there, then that data directly goes to the orthopedic doctor at the first level. So these are examples of use of technology that could increase the speed. Before we have to wait for the X-ray film and then bring the film to the doctor to see and check. So those days are gone. You see, so we need to always keep learning something in our life and improving something, rather than feel enough, just enough with what we have now.
Yes, doctor, I agree with every words that you said just now. Since you're talking about like lifelong learning, so what would your aspirations and goals be for now in terms of personal or in terms of engineering industry, anything related to that?
Definitely I want to excel in my field. Then from that I want to explore how we can collaborate with others and solve the community problem, the world problem, what the people want. So that is my personal aim.
I see, doctor. So to the audience who will be watching, I would say for this podcast in particular would be engineering students and medical students. So what would your advice would be for them in moving forward?
Okay, any student, not only medical students, including my students, I always advise them to be hungry, to stay hungry all the time, hungry of knowledge, always want to learn new things. So this attitude is very important, and don't be scared of things you don't know. normally people scared, even me. I also scared sometimes of things I don't know. But be brave to try to explore things you don't know, and keep learning new things every day. So I think you must have that kind of attitude in order to stay sellable in the market, to stay relevant. You have to just learn everything.
Thank you for the wonderful advice, Doctor. And I think that would comes to an end for our podcast today. Once again, we thank you for your presence here, Dr. Ridha, and thank you for your time and effort putting into this podcast recording session. And we hope to see you soon in future projects. Thank you.
Thank you, Theo. Thank you all. Bye.